Hey geometry kids, it's Mrs. Fallon again. We are going over section 5.2, which is about congruent polygons, and I'm on page 130 in your student journals. Okay, so what we're going to talk about first is this idea of corresponding parts. And so when I ask you about corresponding parts, what I'm referring to is if you're given kind of like, here we go, two congruent triangles. So do you remember what the word congruent triangles or congruent polygons means? Like, what does it mean to be congruent? If you're thinking to yourself, oh, congruent means that, we're talking about all of the same shape, same size. You might have heard that when we talked about rigid transformations. Or you might say all the parts are equal or something like that. That's basically correct. And so what we're referring to here with congruent polygons, in this case it's triangles, we're talking about all of their corresponding parts are congruent. So that means AB corresponds to DE, and so we mark them as congruent. And then likewise, A to C is corresponding and congruent to F to D, so we mark those as congruent. And then B to C and E to F are congruent. So all of those sides are congruent, and all of the corresponding angles are congruent. So when it talks about so if these two triangles or polygons are congruent, then all of their parts are congruent. So I'm going to write corresponding angles and sides are congruent. So when you have a set of two polygons that are congruent, you know all of their pieces are congruent. So if a triangle, you're going to have 3 sets of sides and 3 sets of angles. If it's a rectangle, you're going to have 4 sets of sides and 4 sets of angles. So one of the things we could talk about here is we could talk about like what pieces kind of are corresponding. And so when you match, you would say like A to B is congruent to D to E. Notice that I put this in a certain order. So starting with A and going to B, A matches angle D. I have to start at D and go to E. It would be incorrect to say A to B is congruent to E to D. So you want to make sure that you're kind of doing the same order. So if I say if I say side AC is congruent, and I would say to DF. Again, kind of matching up corresponding pieces with corresponding pieces. And then last, I would say maybe B to C is congruent to E to F. And then you can also name the angles. And so again, when you're using congruent symbols, you're just using you're not using the measure, right? So use the little M in front if you're using equal sign. So we'd say angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. So those are all the parts that are corresponding. So a couple of things that we're going to be talking about. We're going to get into basically proof writing. And so some of the main things that we're going to be referring to are some of these properties that we talked about in previous units. So the reflexive property, the symmetric property, and the transitive property. So if you remember, reflexive property is something we're going to use quite a bit. So what this means for any triangle ABC, that means triangle ABC is congruent to itself. So remember, reflexive property is kind of like that mirror image. It's like something is equal to itself. That's kind of what the reflexive property is. Symmetric is kind of like the commutative property. It means like the opposite order. So if triangle ABC is congruent to triangle DEF, then it's true to say the other way around. Triangle DEF is congruent to ABC. And the transitive property is the one where if two things are congruent to the same thing, then they're congruent to each other. So triangle ABC is congruent to DEF, and DEF is congruent to JKF. So basically, we're kind of like taking out the middleman here, and we're saying, okay, ABC is congruent to JKF. So one of the things I wanted to talk about here is something called a congruence statement. So a lot of times what we'll do, and I'm going to use this as my congruence statement. So I'm going to say triangle ABC is congruent to triangle XYZ. All right, so when you write this is what we call a congruence statement. It's important to understand that in a congruent statement, the order in which we write the letters is important. So for example, in my congruent statement, I know since A comes first, A and X are congruent angles. So I could say angle A is congruent to angle X. Likewise, angle B is congruent to angle Y, and angle C is congruent to angle Z. So the order in which we word these, or the order in which we write these, is telling you what pieces are congruent. So I always think it's easier if you're given a congruent statement to kind of use that order to help you figure out what are your corresponding parts. Sometimes it's harder just to kind of look at the figure and figure out, okay, does this side match this side? You know, sometimes it's easy and sometimes it's not. You can do this with sides as well, like side AB, so segment AB would be congruent to X, because they're in the exact same position, the first two letters, the first two letters. You could say BB is congruent to Y to Z, because again, second two letters. And then you could say A to C is congruent to X to Z. And that's because it's the first and last letter and the first and last letter. So the congruent statement kind of makes a big difference. I think it really kind of helps you to determine like your pieces that are congruent, the corresponding parts. Third angle theorem. It says if two angles of one triangle are congruent to two angles of another triangle, then the third angle must also be congruent. And so some of that's kind of common sense, right? So if we know these two sets of angles are congruent, there's no other choice but to have the other angle be congruent as well. All right, let's talk about another example. So I'm going to give you example 2. I'm going to give you a congruent statement. So DEFG is congruent. So QMNP. So this is obviously 4 letters, which means it's a 4-sided figure or a quadrilateral. So I don't know, I'm just going to try to draw something that are congruent. We'll do my best here. So I'm going to say D, E, F, and G. And then I'm going to go, N, close to being congruent. N, P, Q, and M. All right, so if I have this particular diagram in this congruent sentence, I'm going to give you some information. I'm going to tell you this is 8 feet. I'm going to tell you this angle D, is 102. I'm going to tell you that this angle over here is 84. This angle is 68. I'm going to tell you this is x minus 2 feet, which seems a little weird, right? And then this angle in here is 3x plus 2y degrees. All right, so you would see something like this. What we're going to kind of ask you to do is kind of use our information to find x and y. That's kind of going to be our goal here. So let's start off with, let's say, find x. Okay. All right, so what I might notice is that if I know side, so x has to do with, well, it has to do with the angle and the side, but this side has only x and 2, so I'm going to try to do something with that. So if you look at D to E, it's the first 2 letters. It has to match, so it corresponds with QM. So D to E and Q to M match, which means if they're corresponding, and these two triangles, or not triangles, quadrilaterals are congruent, that means that 8 has to equal x minus 2. And therefore, x would have to equal 10. Now that we know x is 10, first of all, we could call this 30 plus 2y, right? Because I just plugged in 10 for x. And so angle P is going to match what? Angle G. So angle P has to match 84. And so now I'm going to subtract 30. And then I'm going to divide by 2. And so that's kind of how you're going to see some examples of problems and so forth that you're going to be asked to do. All right, let's go to page 131. And on this one, I'm going to do a couple because I'm going to ask you guys to do some of this stuff in class. So we're going to do numbers 1 and 3. So in this first one, it says, identify all pairs of congruent corresponding parts, then write another congruence statement for the polygons. All right, so again, you could look at the pictures or you could look at the diagrams. I think it's always easier to look at, you could look at the congruent statement or you could look at the diagrams. I think it's easier to look at the congruent statement. So I'm going to say angle P is congruent to angle S, just because they're in the same order. Angle Q is congruent to angle T, and angle R is congruent to angle U. And then I'm going to say side PQ is congruent to side ST, and QR, segment QR, is congruent to TU, and then P to R is congruent to STU. So next it says write another congruent sentence. So what they're asking you to do here is that as long as you keep corresponding parts together, there's many ways to write a congruent sentence. For example, if I wrote triangle RQP is congruent. So instead of doing PQR, I did RQP. Then I have to match up corresponding parts. Well, U matches with R, Q and T match, and then S and P match. So another congruent statement that would work, it's not the only one, but another one that would work would be this. So as long as the order here, corresponding parts match up, then that would be a true congruence statement. All right, let's look at number 3. Number 3 gives us, tells us those two triangles are congruent and asks us to find X and Y. So if I'm looking for, it doesn't really matter, I guess, which one we're solving for first. Looks like angle Y is over here. Angle Y and angle S match up. So if S is 30 degrees, and angle Y is 2x minus 20. So I would get 25 to be X. And then for side, because Y is referring to a side, so that's 3y plus 9. At T to S or S to T is going to match Y to Z. So Y to Z. Notice that Y to Z has a congruent mark on it, and it's congruent to this side, which means that it's also 15. So I know that this is equal to 15. So if I subtract 9, I get 6, and then I get 2. All right. A couple more on the next page. And so we're going to be using that particular concept quite a bit in this. The other thing you could do is you could say, well, these two angles are congruent because it forms a linear pair. So we could do, well, if this is 90, then this has to be 90 because it forms a line. And so therefore, all right angles are congruent. And then remember what we talked about in the, so in the one theorem, it said if two angles of a triangle are congruent to two other angles of a triangle, then the third angle has to be congruent. And so I'm going to use the third angle theorem. And that's how I know that that is congruent. So that's kind of my explain your reasoning. All right, number 7. In exercise 7, find the measure of angle 1. So what I did here, I decided, let's see here, what did I start with? I said, if this angle right here is 90 degrees, and so I'm just going to look at this triangle first and foremost, okay? This angle is 33 degrees, I should say. Then this angle over here has to be 33 degrees. And the reason why is because they're both marked as congruent. The other thing I know is if this is 33 degrees, then what is this angle over here? So you probably haven't, so we're going to use that triangle sum theorem. And so the triangle sum theorem says that all three angles of a triangle add up to 180 degrees. Or you could take into account for the fact that this is a right triangle, which means then these two angles here, this one right here, and that one have to be complementary, which means that they add up to 90. So if I subtract 33 from here, I get 57. So that's what this angle down here is. Well, we already know this has to be a right angle. So these two angles together have to equal a right angle. So I'm going to subtract 90 from 57 and get 33. Back to where I started. Measure of angle 1 equals 33. Notice I used the M here, and that's because I had an equal sign. So I'm going to use the measure sign. All right, we are going to move forward, and we are looking at, I'm actually going to do a proof with you. So you can pause the video and write down this proof, and then you can then do it with me if you'd like. So this is a really, really basic proof in the sense that we're going to get into, this is like our first step of congruence proofs, okay? So it says, prove that these two triangles are congruent, and you have to kind of, and then gives you a diagram. So when we do a proof, and we're going to do a lot of them in this unit, you want to take a look at either what's given to you. Sometimes the given is actually literally like said. It says given, and it says, okay, this side is congruent to this side, or this angle is congruent to this angle. In this particular problem, it's not actually said, it's marked. So you have to pay attention to the markings on the diagram. So like, for example, W to X is congruent to Z to V. And then you could say X to Y has 2 dashes. It would be congruent to V to Y. And then W to Y and Z to Y. So WY is congruent to Z to Y. So all of those things were given to me. I'm going to do 2 givens just because there was a lot of stuff. The next thing I'm going to say is now we've shown all of the sides are congruent. So next, I need to show, in order to prove these two triangles are congruent, I have to show that all the angles are congruent. I'm going to say what else is provided in the given. Angle X and angle V are right angles. I mean, isn't that what's marked in our diagram, that they're right angles? And so this is given to us. Well, we learned a theorem way back when about all right angles. What do we know about all right angles? If you answered that they're congruent, you are correct. So you would say angle X is congruent to angle V, and your reasoning would be all right angles are congruent. All right, so we got that angle. All right, what's next? What other kind of angles do we have? Well, this is another one that we're going to be using quite a bit. So remember how I talked about the reflexive property going to be a very popular, property that we're going to use when we prove triangles are congruent. Well, this next one is also a popular one. Think about why I know that these two angles are congruent. And so we're reaching back to what we learned in the first few units. And I told you this stuff is going to keep cycling back around. These angles right here, this angle over here and this angle over here, we can't call it Y because Y kind of refers to both of those angles there. They are congruent. And the reason why is because they are vertical angles. So in statement 4, I'm going to say angle WYX is congruent to angle VYZ. So WYX is congruent, whoops, I should put this in the wrong order. WYX, so it should be ZYV. I have my ZYV. Okay, so I'm going to say those two things are congruent because of vertical angles. So vertical angles are congruent. This is going to be a very popular statement. So we're going to be looking out for vertical angles. I call this kind of like my hidden information. And the reason I say that is because it's not like super obvious. It's just kind of, you have to recognize it. Okay, well, I've got all my sides. I've got 2 sets of angles now that are congruent. I have to show one more set of angles. I can say angle W is congruent to angle Z. First of all, notice that I used one letter here. And the reason why is because there's only one angle in this triangle that has a W on it, and only one angle in this triangle that has a Z on it. Whereas angle Y had 2. So that's why I had to use the 3 letters here and only the 1 letter here. All right, so we're going to go back to that one theorem that we talked about on the previous page. The third angles theorem. And it basically states if you know that 2 other angles in the triangle are congruent, then the third one has to be congruent. We always end our proof with what we're trying to prove. So in this case, we said triangle WYX or WXY is congruent to triangle ZVY. And my reasoning is all corresponding parts, which means all their angles and all their sides, are congruent. So in order to prove that was congruent, I showed that all the sides were congruent and all of the angles are congruent. And so that would be kind of a complete proof for that particular problem. All right, that's it for today. If you have any questions, I encourage you to try some of the practice on big ideas. And if you have any questions, bring them to class. All right, bye for now.